Next, we want to look at an experiment that was done that gives us a lot of information about the makeup or the structure of atoms. This experiment was done by a scientist called Rutherford, who took a piece of gold foil. Gold is an element that can be hammered into a very thin sheet. So basically, you have a sheet of gold that has a thickness similar to tissue paper, and then into that gold foil, Rutherford had a source that would release what are called alpha particles. And what's important for you to know about alpha particles are two things. First off, they're relatively heavy and they have a net positive charge. So we're shooting something heavy at a piece of essentially tissue paper, so most of the particles should be expected to go straight through and hit the detector on the other side right here. However, there were some interesting results to the experiment. You had some alpha particles that did not hit where they should have hit if they just went straight through the tissue paper. So somehow they got deflected. And most interestingly, you had some alpha particles that, when they hit the tissue paper, would bounce almost straight back, coming back towards the source of the alpha particles. So based on these experiments, before Rutherford did his work, what was expected was almost all the alpha particles, or all the alpha particles rather, should just go straight through the tissue paper. The makeup of the atom was called the plum pudding model. So this is what Rutherford expected. However, the deflected particles and the particles that bounce straight back lead us to this new picture. So what we're seeing is most of the alpha particles do pass through the gold, and they're not bouncing back and they're not being deflected. The ones that are being deflected at a certain angle, remember, they have a positive charge to these alpha particles. And positive charges, when they come close to another positive charge, there will be a repulsion between two charges of the same sign. So the explanation is an alpha particle gets close to something that has a positive charge, gets repelled, and therefore gets deflected off its normal course. The particles that bounce straight back, there weren't very many of these. Most of the alpha particles did do what we expect, but some of them must have hit a region of very concentrated mass and then were able to be deflected back towards the source of the alpha particles. So this region of concentrated mass we call the nucleus. So this picture summarizes our understanding of the structure of atoms. Most of the atom is empty space. And if the alpha particles pass through this region, there's going to be no deflection and no bouncing back. The nucleus is very small in size because very few alpha particles hit that. We know it has a positive charge to it because of the deflected alpha particles, and we also know that this nucleus must be very massive. So most of the mass of the atom is contained within the nucleus. We now know that there are three types of particles that make up an atom. We have electrons, which exist in this region, which we said was mostly empty space. So it's not exactly empty, but we have those electrons there. And then we have protons and neutrons that reside within the nucleus. And this is definitely not to scale. If you had the nucleus to scale, it would be very difficult to see on a picture of this size. So if this is an atom, a nucleus would be much smaller than what this diagram is showing you. So to summarize, all together we have 3 alpha particles. We have protons, which we'll abbreviate with a P, and we'll write a positive superscript. That means it has a positive charge. And a proton has a mass of 1.0073 atomic mass units. Now, you don't need to memorize a number like that. I'm just going to compare to the other 2 atomic particles. The next one is a neutron, just abbreviated with an N. It has no charge, and its mass is slightly heavier, 1.0087 atomic mass units. And then lastly we have the electrons, which have a negative charge, and relative to protons and neutrons, electrons are extremely light, 0.00055 atomic mass units.